Ayubowan, everyone, and a very warm welcome to Study Hub Sri Lanka. I'm so glad you're here. Today, we're going to dive into one of the most important chapters in your science textbook, the structure of matter.
So, we're basically going to explore the building blocks of our entire world. By the time we're done with this lesson, you'll have a super clear picture of how everything around us is actually put together.
Here's our roadmap for today. We'll start by looking inside the atom. Then we'll make sense of the periodic table, figure out how to find any element, see the difference between metals and nonmetals, and finally, learn how to write chemical formulas. You ready? Okay, let's get started.
Right, first things first, we need to understand what everything is actually made of, and that brings us straight to the atom. So as you can see, an atom is made up of three key particles. You've got your protons, which are positive, you have your electrons, which are negative, and then you have neutrons, which have no charge at all. Now this is really important. A normal atom is electrically neutral because the number of positive protons is perfectly balanced out by the number of negative electrons.
Now here's something that might blow your mind. An atom is mostly just empty space. I love this analogy. If an atom was the size of a whole football ground, the nucleus, where all the heavy stuff like protons and neutrons are, would be smaller than a single chickpea right in the middle. The rest of it is just empty space with electrons whizzing around. Amazing, isn't it?
So, if there's one thing that defines an element, it's this, the atomic number. Think of it like an element's national ID card. It's totally unique. For example, any atom that has exactly 6 protons is always carbon, no exceptions. It's what makes carbon, well, carbon.
Next up is the mass number. The main thing to remember here is that electrons are incredibly tiny, so light that their mass is basically nothing when we're calculating this. So, to get the atom's mass, we just add up the heavy particles, the protons and the neutrons in the nucleus. Simple as that.
All right, let's make this real with an example. Take a look at this table for sodium. We're given the atomic number, which is 11. What does that immediately tell us? Exactly, it has 11 protons. And since the atom is neutral, it must also have 11 electrons to balance things out. Now, the mass number is 23. To find the neutrons, we just subtract the number of protons from the mass number. So 23 minus 11 gives us 12 neutrons. See, it's pretty straightforward.
Okay, let's move on to our next section. Let's see how all of these different kinds of atoms are organized in a really clever way.
I mean, with over 115 known elements, can you imagine trying to memorize them all? It'd be impossible. That's why scientists came up with this amazing system, this organized map to keep track of them all. And that map is the periodic table. This is kind of the golden rule for the whole table. It basically means that when you line up all the elements by their atomic number, you start to see patterns. Elements with similar properties, like maybe they're both shiny metals or they're both gases, they show up at regular, predictable intervals. It's this repeating pattern that gives the table its famous shape.
So how exactly do we read this map? How do we find an element's exact location, or its address, on the table?
Well, the secret is all in the electrons, specifically how an atom's electrons are arranged in different layers, or shells. We call this the electronic configuration.
The horizontal rows that go across the periodic table are called periods. Finding an element's period is actually really easy. All you have to do is count how many electron shells it has. So if an atom has its electrons spread out across 3 shells, it's in period 3. That's it. That's it.
And the vertical columns, the ones that go up and down, are called groups. An element's group is decided by the number of electrons in its outermost shell. These are called valence electrons, and they are super important because they're the ones that get involved in chemical reactions. They basically decide how an element is going to behave.
Okay. Okay, let's put it all together with magnesium. So magnesium's atomic number is 12. That means its electronic configuration is 2, 8, 2. Right, first, the period. How many shells do we have? 1, 2, 3. So it's in period 3. Now for the group. We just look at the number of electrons in that last outer shell. And there are 2. So that means it's in group II. Simple.
Great.
Now that we know how to find our way around the table, let's look at the two big families that all the elements fall into.
You see, the periodic table has a pretty clear divide. We've got metals and nonmetals. Metals, which you'll find on the left and in the middle, are usually shiny and you can hammer them into different shapes. That's what malleable means. Nonmetals, over on the right, are pretty much the opposite. They're usually dull, and if you try to hammer them, they'll just shatter.
All right, for our last section, let's learn how to speak the language of chemistry. We're going to figure out how elements combine to make compounds like water or salt, and how we write that down.
And the key to this whole thing is something called valency. You can think of valency as an element's combining power. It tells us exactly how many bonds an atom can form, which is what we need to know to write our formulas correctly.
This table shows a fantastic little trick called the crisscross method. Let's make calcium chloride together. Step 1. Write down the symbols Ca and Cl. Step 2. Write their valencies right below them. Calcium is 2, chlorine is 1. Step 3 is the crisscross. You just exchange the numbers. Calcium gets the 1 from chlorine, and chlorine gets the 2 from calcium. That gives us our final formula in step 4, CaCl2. Notice we don't write the 1. Whew, okay, that was a lot of information, I know. So let's just do a quick recap of the most important things. These are the core ideas from this chapter that you really need to remember.
And I want to leave you with a final thought to chew on. Think about this: a rock and you, a living person. You're both made from the exact same building blocks on the periodic table. So what is it that makes a living thing so different from a rock? It's something to think about, isn't it? How these simple rules create such incredible complexity. And that's a wrap on the structure of matter. Thank you so much for joining us at Study Hub Sri Lanka today. Keep studying hard, go back and review these ideas, and we'll see you for the next science lesson.
That's all for today, children. Thank you for learning with me. Please subscribe to our Study Hub Sri Lanka YouTube channel and click that bell icon so you won't miss our next science lesson. We will meet again soon.